So exclusively today, we are going to teach you how to measure your existing camshaft profile using our degree wheel kit before adjusting it in the final episode. Besides the full range of tools stated in the previous episode, you need the camshaft measuring data schedule to jot the measurements taken. The first step of the camshaft measurement is to find the position of the piston top dead center, TDC. Loosen the degree wheel axle, place it at 0 at top dead center. At the degree wheel, align it with the dial indicator that also shows 0 and then tighten the degree wheel axle. To double check, rotate the degree wheel anti-clockwise according to the dial indicator to 50, 0.5 millimeters, showing the degree wheel at 10 degrees. Once done, return to the initial position 0. Then, rotate the degree wheel clockwise according to the dial indicator to 50, 0.5 millimeters, showing the degree wheel at 10 degrees. If you attain these readings, it shows that you are on the right track. Continue to remove the dial indicator and install the camshaft. For this series, we will be using an R3 camshaft. Install cam stopper and cylinder head, followed by an adjustable timing gear, ensuring the position mark on the timing gear is in a vertical position. Along this process, keep in mind the position of the degree wheel has to be at 0 degrees at the top dead center. Untighten the tensioner, observing the degree wheel is at 0 degrees, aligned with the vertical position of the timing gear and the marking on the cylinder head. And then, install the necessary mountings on the cylinder head. Use the feeler gauge to precisely check the valve clearance. In this case, the valve tappet clearance will be 0.08 millimeters. Gently slide the feeler gauge in between the top of the valve stems and the part of the mechanism which presses to open the valves. Adjust it with the tappet and the conventional spanner until the feeler gauge can comfortably slide in between with minimal interference. Measure and adjust all 4 valves. Once done, reinstall the dial indicators, ensuring the dial indicator pointer is linear with the angle of the valves at 0 without any interference. To measure the existing camshaft profile, first, measure the exhaust valve open at 1 mm at the dial indicators. Here, you will get a measurement of 61 degrees before bottom dead center. Jot the measurements down on the camshaft measuring data schedule. Next, we will be finding the maximum exhaust valve lift. Rotate the degree wheel anti-clockwise until the needle at the dial indicator stops and reverse slightly, showing 8.65 millimeters at the dial indicator derived from 8 full rotations shown at the inner indicator and 0.65 millimeters at the outer. Write it down at the camshaft measuring data schedule. Continue the rotation of the degree wheel and it will succumb to the closing of the valve. Continuing the process 1 millimeters until it fully closes. At the degree wheel, we will get a reading of 22 degrees after top dead center. Write the measurement taken in the camshaft measuring data schedule. As how it was measured for the exhaust valve, now apply the same procedure for the intake valve, starting with the intake valve open at 1 mm at the dial indicators, giving you a measurement of 33 degrees before top dead center. Maximum intake valve lift is 8.59 mm at the dial indicator and 47 degrees after bottom dead center at the degree wheel for the measurement for intake valve 1 mm before closing. And there guys is the complete measurements taken to fill in the camshaft measuring data schedule. That's all for